Hi, Mr. Richards here, and today's lesson is on adding linear expressions. Our objective today is to add linear expressions and find perimeter by adding linear expressions. Now, a linear expression is an algebraic expression in which the variable is raised to the first power. Now, you can use models to add linear expressions, and we're going to try to do that here. We have 4x plus 5 plus 3x plus 7. Now, if we use a model, for the 4x's, we could say, okay, here is 1x, 2x, 3x's, and then there's 4x's. So that's my 4x. Then I have plus 5. Well, what if I do each of those as just little squares? 1, 2, 3, 4, and 5, and each of those represents 1. So that's 4x plus 5. And then what if I do the same thing for my 3x plus 7? So I would have 1, 2, 3x's, so 1, 2, 3x's, and then 7 of my little 1s. So 1, 2, 3, 4, 5, 6, and we'll put the 7th there. And again, each of those just represents 1. So here I have my plus 3x plus 7. Now, let's regroup these. Let's regroup our x's together because those are like terms. Well, I would have 1, 2, 3, the 4 x's here, and then my other 3 x's. So 1, 2, 3 x's, and then my 5, 1, 2, 3, 4, 5, and then 7 more. 1, 2, 3, 4, 5, 6, and 7. And each of those are also 1 again. So what do I end up having? Well, 1, 2, 3, 4, 5, 6, 7 x's plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, just 12 constants. So 7x plus 12 then is my simplified expression. Now, how else can we do that? Well, if we have just the expression 4x plus 5 plus 3x plus 7, let's go ahead and group our like terms just algebraically. So I would have my 4x I could draw a box around, and my plus 3x I could draw a box around. Now notice I included the plus sign to the left of the 3x. And then if I put circles around my constants here, my plus 5 and my plus 7, because constants are also like terms, I end up, if I rewrite this as 4x plus 3x, if I just group my x's together, then plus 5 and plus 7. Well, once again, 4x plus 3x is 7x. 5 plus 7 is 12. So if you need to use the models to try to see what's going on, use the models to see what's going on. But eventually, it would be good if you can solve these questions without the models. Now we're going to try to solve this one without models, actually, to see a method of doing this without models. We have negative 3x plus 8 plus negative 2x plus 2. Well, let's arrange these in columns with the like terms. So we would have negative 3x plus 8 plus here negative 2x plus 2. Now we're adding here, so we can just add our 8 plus 2, and that's a plus 10. And our negative 3x plus a negative 2x is a negative 5x. So our final answer is negative 5x plus 10. Again, that's just one way without models of doing this. What if we tried something similar to what we did in example A? Negative 3x plus 8 plus negative 2x plus 2. What if we try to do our box and circle thing? We put a boxes around our negative 3x and our plus negative 2x, so we have just horizontally negative 3x plus negative 2x regrouped. And then we have our 8 and our 2, so plus 8 and plus 2. And so again, you can see negative 3x plus negative 2x is negative 5x. And 8 plus 2 is a plus 10. So either way you solve this, you'll get negative 5x plus 10. Some of us may prefer writing the common terms in columns. Some of us might prefer our boxes and circles and regrouping it that way. Either way ultimately will work. Learning both would be even better. Now in this question I do want to show you how to do models because we have a positive and negative here with x, and there is something special that we could do here with those. So we have 4x minus 3 plus negative x plus 5. So let's draw our models like we did in our first example. We're going to have 4 x's. So let's go 1, 2, 3, and 4 x's. And then minus 3. For the minus 3, let's draw these in green. So minus 1, and minus 1. There's our minus 3. And our negative x, let's draw that in blue. We're going to have a negative x. And then for our plus 5, well, let's do that in a different color. I'll use purple for this. So we have 1, 2, 3, 4, and 5. Now let's go ahead and regroup our like terms. So let's group our x's together. We have 1, 2, 3, 4 x's. And then we have our negative x with those. And then we have our 3 negatives. It's a minus 3, so we'll just treat those as negatives. Negative 1, negative 2, negative 3, with then our positives ones. Positive 1, positive 2, 3, 4, and 5. Now what ends up happening here, things cancel out. 0 pairs. Remember, negative 1 plus 1 is 0. Again, something like 1 plus negative 1 equals 0. So we can take this x plus negative x here, and that just cancels out. As does this negative 1 plus 1, this negative 1 plus 1, and this negative 1 plus 1. So ultimately, what are we left with? Well, I see 3 x's and 2 positives 1, so plus 2. 3x plus 2. And that's our final answer here. Now, what if you'd like to try this without models? Well, if we set this up in columns again, where we have our 4x minus 3 plus negative x plus 5, well, what is negative 3 here plus a positive 5? Well, negative 3 plus a positive 5 is a positive 2. What is 4x plus a negative 1x? Well, that is 3x. So again, we get the same 3x plus 2. And if we'd like to try this just writing it out, 4x minus 3 plus a negative x plus 5, and we try our boxes around the 4x and the negative x with our circle around the negative 3 and the positive 5, we would have 4x plus negative x. Remember, negative x is the same thing as negative 1x. Plus negative 3. Remember that minus sign gets to the left. We're going to treat that as a negative 3. Plus 5. Well, 4x plus negative 1x is 3x. And negative 3 plus 5 for the second time, or third time maybe, is plus 2. So again, we have three different ways, one with models, two somewhat algebraic here, one in columns, the other more horizontal, and how you can solve these questions. Again, pick one, pick two, however you'd like to solve these, and just get it done. So, using linear expressions to find perimeter now was the second part of our objective. So a rectangle has a length of 4.6 x units and a width of x units. Well, let's draw that out. We have somewhat of a rectangle there with a length of 4.6 x units and a width of x units. And find the formula for the perimeter of a rectangle. Well, the perimeter of a rectangle is P, a perimeter, equals 2 times the length plus 2 times the width. Well, for our length, we could substitute in that 4.6x. So this would be P equals 2 times 4.6x plus 2 times our width of x. Now we need to simplify this, so P is going to equal, we can multiply these 2 times, or multiplied by 4 6/10 is 9 2/10, so we can write that as 9 2/10 x plus 2x. And now we can combine the 9 2/10 x plus 2x. So my perimeter is going to equal 11 2/10 x. So that's going to end up being my formula for finding the perimeter of that rectangle. Now we're being asked, find the perimeter of the rectangle if its width is 3 2/10 meters. Well, conveniently enough, it's saying our width is x. So this width of 3 2/10 can be substituted in for that x, or in other words, this x right here. So we have P is 11 2/10 times x, and again, it's convenient that our width here is x, and we're given our width here, so we just need to put it in there for x. So perimeter is going to equal 11 2/10 times 3 2/10. And when you multiply those two numbers together, your resulting perimeter is 35 84/100 meters. And that's our final answer there. Now in this question, for the figure, write and simplify our linear expression for the perimeter of the figure. Then find the perimeter of the figure if x is 8/10. Well, perimeters of triangles are perhaps a little more straightforward than perimeters of rectangles. Well, rectangles, we have that formula. Perimeters, we just simply add them up. So our perimeter here is going to equal 8x minus 4 plus negative 2x plus 10 plus 10x plus 2. Now, if we use our column method, we can rewrite this as 8x minus 4 plus a negative 2x plus 10 plus 10x plus 2. Now we have a negative 4 plus 10. Well, negative 4 plus 10 is positive 6. And 6 plus 2 is a positive 8. Then we have 8x plus a negative 2x. Well, 8 plus negative 2 is positive 6x. And 6x plus 10x is 16x. So we have 16x plus 8. Again, that's one way of writing this. Now, another way is saying, okay, we have 8x, a negative 2x, and a 10x. So this would be equals 8x plus negative 2x plus 10x. And we have a minus 4, positive 10, positive 2, so plus a negative 4 plus 10 plus 2. And we're just basically adding it the same as we just did, except we're writing it more horizontal. 8x plus negative 2x is 6x plus 10x is 16x, so 16x. And negative 4 plus 10 is 6, plus 2 is 8, so plus 8. And again, the reason I keep showing this multiple ways is because you may prefer one method over another. And so, again, do whichever method you're most comfortable with. So we have our linear expression simplified to be 16x plus 8. And we're being told that x is equal to 8/10. So we need to take that 8/10 and substitute it in for x and solve. So 16 times 8/10 plus 8. 16 times 8/10 is 12 and 8/10 plus that 8. And 12 and 8/10 plus 8 is 20 and 8/10. Get my decimal point in the right spot here. 20 and 8/10. And we're not given a unit here, so we can just write this as 20 and 8/10. Actually, no, we are. We're given the unit centimeters. So let me go back and erase that. It is 20 and 8/10 centimeters. And there's our final answer, 20 and 8/10 centimeters. So we can add up the expression, have a simplified expression, and make our substitution in. Make sure we use our units. And that is that. That's it for this video. Good luck.